Case 4, balancing of several masses rotating in different planes. So we saw case 1, case 2 and case 3. So case 1 was of single mass in single plane. Case 2 was of single mass in different plane. Case 3 was of several masses in one plane. Now we have several masses in different planes. So all the masses rotate independently in different in different at different distances or different planes. So yeah. So as you can see, a mass. So we consider an example for. So here, what is the condition to make the system as balance? So when a revolving. So I will consider the first example for this. Consider four masses M1, M2, M3, M4. As you can see, 1, 2, 3, and 4 attached to the rotor at radii R1, R2, R3, R4 radius respectively. The masses rotate in the planes. The masses M1, M2, M3, M4 rotate in the planes 1, 2, 3, and 4 respectively. As you can see, the space diagrams, these are called as space diagram. Left and right ones, A and B. Left shows the position of planes. So as you can see, position of planes from the, and right shows the angular positions of theta 1, theta 2, theta 3, theta 4. So these are the four unbalanced masses. The system is already in unbalance. So choose a reference point. Means we will introduce a balancing mass at O or at plane L, and one more balancing mass EM between 3 and 4. That is it. So the now carry out the distances. So we'll choose L is the balancing mass between 1 and 2. M is the balancing mass between 3 and 4. So these are the unknown masses. L and M are the unknown masses. So and the angles will be alpha and beta, alpha and psi. So we'll find these angles also. So now we'll choose the reference plane L as the reference plane. So from this L we will measure all the distances of other masses. So from L to mass 1 is L1, L to mass 2 is L2. Similarly, L2 distance mass 3 is L3. So L2 distance mass, the other balancing mass EM is LM. L2 distance mass, the balancing mass, the 4 is L4. So yeah, and here since L is a reference plane, so the distance between to the left side of L we will take it as negative L, negative. So that will be L1 will be minus L1, and distance to the right side of the reference plane will be taken as positive. That is L2, L3, LM and L4 becomes plus positive. So now after this, the next step is to tabulate. Step is to tabulate a tableau column. So tableau column consists of plane, and next is mass, third is radius, fourth is centrifugal force M into R, fifth is the reference distance between reference plane, sixth is the couple. We can one more add the angle of reference. So note down the planes in a order. So first is plane 1, then comes plane L, then comes plane 2, after 2 comes plane 3, after 3 comes plane M, after plane M comes plane 4. Write down the corresponding mass of plane 1, that is M1, L, that is ML, plane 2 is M2, plane 3 is M3, plane M is M, plane 4 is M4. Radiuses R1, plane L is RL, considers RL, mass 2 R2, mass 3 R3, plane M we consider mass M, that is we consider radius is RM, plane 4 is R4. Now multiply mass and radius, will get the centrifugal force divided by the neglecting the angular velocity, which is common. So we have m1 r1, ml rl, m2 r2, m3 r3, m4 mm rm, m4 r4. Since the reference plane is L, yeah, so reference plane L becomes 0. L21 is minus L1, as we can saw. As from L, it is L1 is to the left side of this. 0 to L2 is L2. 0 to L3 is L3. 0 to L4 is L4. 0 to LM is LM. 0 to L4 is L4. Now to get the couple, just multiply the central force into distance. Just multiply the column 4 and column 5 to get column 6. So m1 r1 l1 minus l1 becomes minus m1 r1 l1, ml rl into 0 becomes 0, m2 r2 l2 becomes m2 r2 l2, m3 r3 l3 becomes m3 r3 l3, mm rm lm becomes mm rm lm, m4 r4 l4 becomes m4 r4 l4. So these are the couple formed based on the given data. Now first we'll draw the couple polygon. So based on the unknown terms. So first to draw the couple polygon, that is the figure C, as you can see here, figure C. So first to draw first couple polygon, that is 0 dash to A dash. So 0 dash to A dash, that is C1. So we should draw the opposite direction, that is to left side, since it is negative. So draw a particular scale O dash to A dash. Now from A dash, take angle with respect to the second couple, that is the mass 3, mass 2, and draw the second couple at angle theta 1 from A dash to B dash, that is C2. Now from B dash with theta 3 angle, draw the third couple, that is C3, taking the convenient scale. So draw B dash to C dash. So once again from C dash, taking the angle theta 4, draw the fourth couple C4 at theta 4 angle from C dash to D dash. So the couple is incomplete, so it is unbalanced, as you can see. So join the unbalanced by D dash to O dash, drawing a dotted line. So this is proportional to the unbalanced, that is LM. Okay, so first we'll now the vector CM, that is LM, that is equals to a vector the line D dash O dash, or the mass, unknown mass. If you want to find the unknown mass, so vector line upon LM, so we get the mass, unknown mass. Similarly, now after finding this, so we have to draw the force polygon. So now again, force polygon, we have to consider the force polygon values. So first m1 r1, that is draw value fc1, that is m1 r1 value from O to A in the force polygon. Now taking angle theta 1, draw line fc2, that is m2 r2 value from theta 1 angle from A to B. Now from angle B, draw fc3, taking angle theta 3, the m3 r the value, draw from B to C. Now from C, taking angle of theta 4, draw the central force m4 r4, that is fc4, from C to D with theta 4 angle, draw it. Now with fc into m, this is now mass m is known, so draw fcm at an angle, the angle which we found from the couple polygon. So that angle should draw from D to E. Now since it is unclosed, now the force pole is unclosed, it is unbalanced. So join E to O, which is the unknown centrifugal force or resultant centrifugal force. So join EO with a dotted line, that is FCL. So measure the line EO, vector EO. Now as we know that MLRL is vector EO, or ML mass L is vector EO upon RL if RL is known. So yeah, I get the mass of balancing mass of the mass RL and RMs. So once again, so we have to draw the fixed space diagram, locate the unbalanced balancing masses positions, fix. Now next, choose the reference plane, and anything to the left to the reference plane is negative, anything to right of the reference plane is positive. And draw the tabular column with plane, mass, radius, centrifugal force, distance of reference plane, and couple with angle along with angle. Next, plot the datas. Write the datas, multiply column 2 and column 3 to get column 4, that is centrifugal force MR. Multiply centrifugal force and column 4 and column 5, centrifugal force and distance of reference plane to get the couple MRL. Then draw the couple polygon with a suitable scale. Draw the line, touch the unknown line, that is D dash O dash. Find the unknown line D dash O dash. Then find the with the couple, find the with the formula M mass, find the unknown mass, balancing mass mm. Again with the draw the force polygon with the same values from the centrifugal force, and draw the centrifugal force unknown mass. So with the formula MLRL vector EO, ML is vector EO upon RL, so we get ML. So this was about the case 4.